Even functions are said to be symmetrical about the y-axis, and they follow this formula. It says f of negative x should equal f of x if a function is even. All that means is that if I fill in a negative value for x and I fill in the same positive value for x, I should get out the same y value. So let's check our graph. If I fill in negative 2 for x, I get out positive 4 as my output value. So when I fill in 2, I should also get out 4, which I do. We can see that the graph reflects itself across the y-axis. Functions are said to be odd if f of negative x equals negative f of x. All that means is that if I fill in a negative value for x, I should get out its opposite if I fill in the positive value. So let's check that. When I fill in, let's say, negative 2 for x, I get out, looks like negative 8 right here. And I should be able to fill in positive 2 and get out the opposite of negative 8, which would be positive 8. Let's check that. If I fill in positive 2, my output is right here at 8. And you can see on the graph that the function does reflect itself twice. Once about the y-axis, produces something that looks kind of like this, and then reflects itself again about the x-axis, producing this. Some functions are said to be neither even nor odd. For instance, the graph over here on the left you may want to say is an even function because there is symmetry. However, the symmetry is not about the y-axis. It's here about the line x equals 4. We should be able to say algebraically that, remember, f of negative x should equal f of x if the function is even. And I can check if that's the case, then I should be able to say that f of 6 right here, which gives me 4, should give me, at negative 6, I should get the same thing. Well, at negative 6, I don't have a point at all, so I know this is not an even function. Over here, you may be tempted to say this is an odd function. And let's check that on the graph first. We know that it has to reflect itself across the y-axis, so we can see that it would be like this, and then the reflection must be across the x-axis, which means that this graph would have to jump down something like this, which is not the case. It reflected right here across the horizontal line, y equals 2. And we can check it algebraically as well. We know that f of negative x should equal negative f of x. Remember, they should be opposites. So I should be able to take a negative x value over here, let's say negative 3. I should be able to take a negative value here at negative 3, and its y value is negative 1. So if the function is odd, I should get the opposite of negative 1, which would be positive 1 when I fill in positive 3. And if I fill in 3, I go up here and I check, I get positive 5, not 1. So this is not an odd function.